with the presentation today. Let me get this right. There we go. Okay. Yeah. So thanks for being here. I am Charlie Hutto. I'm the program coordinator for the Over Dimension Permit Unit for the Oregon Department of Transportation. I'm going to talk to you all today about the lane-based over height routing that we do in Oregon for oversized trucks and how it works and why we did it and how we did it and kind of some of the pros and cons of the program as well as we've been dealing with it. So kind of a brief history of how we've done things. So I've worked in the OD permit unit since 2004, so getting on to 22 years now here pretty soon. When I first started, we used what we called the height manual to route over height loads, and this big thing, it was about I don't know, 2 or 3 feet thick of paper that we all kept on our desks. And whenever we had an over high load, we'd leaf through it and thumb through it based on our highways and figure out if a load of that height could make it over the route they were requesting. And of course, there was a lot of human error potential with that. And whenever a new height came out, we'd be handed out papers by our leads. We have to stuff them in the envelopes and everything. And it worked, but it was, like I said, a lot of human error involved in that. So, and those heights were all done. I have there with sticks, kind of as a little bit facetious, but I really do think they were out there for some of the heights that we got just with like tape measures, trying to figure out what the height was under a certain structure. We had some of our heights were from the 1960s that we had, so certainly could have changed in the 40 years since we in the early 2000s. In 2013, we switched over to our badly named electronic routing manual. That was where we had all of our heights put into a DB2 database, and then staff can query against that for over height loads, trying to route those across the state. So better because we had much more control over it. We could look at the data and control it ourselves without having to count on staff stuffing things and things on their desk. We also switched over to a laser based system to get the heights for our for our structures. So I think it was called the VCMS, or the vertical clearance measuring system, or something like that. So the way that it would work is they would drive around and they have these lasers mounted on the back of a truck, and they would pass it twice and get 4 measurements, and then tell us what the lowest height was under under a certain structure in a certain lane at a certain highway and milepost. So it worked okay. Got through. We did that for a few years. Then it kind of wore out, and it was hard to get replacement parts. So we switched over to a LiDAR-based system in 2018. So our geometronics unit, which I'll talk more about them throughout this presentation, they got a new LiDAR system. They want to use mobile LiDAR, and then we learned we could use that system to get vertical clearance data out of. And so we are using that, have been using that now for the last several years to get data. And then today, we're still using the LiDAR data, but we're using Orion for routing. Orion is our automated routing and permitting system. Orion stands for Oregon Routing Information Online. We got a cool acronym as well. And we've been using that since the middle of May of this year, so about 7 months. And we've been doing it very successfully, and we're very happy with it. I'll try to remember to talk about the pictures. All the pictures on here are Oregon-based pictures. Some of them may or may not apply to over high loads. It's just our windiest, nastiest, awesome highway to drive a car on. It has a 35-foot length restriction on it, and I don't know. Every few years, somebody drives their GPS off into oblivion, like this car hauler did. So why did we want to do lane-based routing in Oregon when we implemented Orion? The first one is we've always done it that way. Certainly since I started in 2004, and even in decades past, we always routed to a certain lane height. So we've done it for decades and decades. And just because we had a new system, we didn't want to stop doing that. We wanted to make sure each lane under a structure had its own height, and then we could route appropriately underneath it. The second one there, we prefer to keep the big things on the freeway, because that's where they belong. Freeways have faster traffic, wider lanes. The traveling public is used to seeing bigger things on the freeways as opposed to 2-lane highways. So we like to keep stuff on the freeways as much as possible. We do apply a 4-inch buffer to all the heights. So we get real heights, from our geometronics and our bridge unit for what the heights are. But we have an administrative rule that requires us to take 4 inches off of that height. And we almost never route into that height buffer. We have some extremely rare situation. I can think of maybe 4 or 5 in the time I've been with ODOT, or we have routed into the height buffer. So it just doesn't come up all that much, fortunately. And we almost never will route into it. We'll route them around or route the carrier another way, as opposed to encroaching into that 4-inch buffer. The big deal for all of this is that safety is still the highest priority. Just because we got a cool new system, we don't want to start jeopardizing safety. Obviously, the motor carriers, they don't want to be hitting structures. We don't want them hitting things. That can be potentially catastrophic. So we want to make sure we don't lose any of that. So safety is still the biggest big deal in all of this. The cool picture here, this is from a few years ago, Superload that we routed in Central Oregon on a 2-lane highway, and our public affairs guys, they found out we were routing this big giant thing, and so they got out there and got the cool picture with the barbed wire fence in the front, mount hood in the back. Just kind of a cool picture I try to put on all my PowerPoints. So how do we get the data? So as I mentioned, our geometronics unit, they collect the LiDAR data and they process it and do magical things with it that I don't quite understand. But they end up kicking out height data for us, and they hand the data off to our bridge unit, and the bridge unit, they're officially the ones that provide the vertical clearance data to us. So they review it, give it to us, we review it, and then give it to ProMiles, and then ProMiles reviews the data. And I'll stop there just to talk about all the different review processes. Why we do that is we're still learning, to trust the system. We're not quite ready yet to have, geometronics collect it and then it just show up in Orion. We still prefer to have a few checks in there just to make sure everything's okay. Because especially if we lose vertical clearance, we may get asked about that from the industry, like why could I go yesterday, but today it's a lower height? And we like to be able to address those questions with what happened, maybe bad measurements, paving project that nobody told us about, or whatever it was. We try to avoid those things and avoid vertical clearance losses. They do happen from time to time, and we like to know about it. So that helps with the review process. Same thing if there's a great increase in vertical clearance, like it increased 1.5 feet or something, we kind of want to know what happened with it and what changed and what went on. So we like to review those things. Anyway, getting to the last there, ProMiles, they will then add it to Orion with the 4-inch buffer, and they do it in feet and inches is how it gets added into Orion, and it works good. And then permits routed, and we all live happily ever after. This picture, was from a few years ago when you could actually do 2 windmill blades on one load, and now you can't do that. They're just way too big. But this is kind of a cool picture where it's getting ready to make a left turn onto a county road there off of our state highway and go out to a windmill farm. Kind of cool. Okay, so applying data to the system. So we provided data to ProMiles in a standard way, and there's some samples coming up here in a second. The big one that we learned a lot about was latitude and longitude. We're learning now how lat-long centric automated systems are and how the mapping and the routing and everything works. So it's a very lat-long centric. We provided a description of the structure to them, and we'll talk more about some issues we had with that when we were handing that off. We have lane clearance measurements for up to 6 main lines. So in Oregon, I think the most we have is 4 lanes on any freeway. We built our original system for up to 6, just in case they expanded it. We didn't want to have to change our database just for new highway measurements, or for new highway infrastructure. So we had it set up for up to 6, but in reality, we only had 4, and a lot of our freeways will only have the 2 lanes. I will mention, I'll say freeway a lot in this, but we do have vertical clearance for all of the state systems. So that includes 2-lane highways that sometimes have bridges or pedestrian structures over them or things like that. We also have left turn maneuver measurements, and then entrance lanes and exit lanes, and lots of things to keep straight because it is important to us. Where is that bridge? Is it on the main line? Is it on an exit lane? Which lane of the exit lane? If it's a 2-lane exit lane, so all that was important to us to try to get that right. So this is just a sample of the data that we provided, and we'll talk a lot about this. This is a sign bridge in the north end of Portland, where I-5 and I-405 come together. I have a picture on the next slide. We'll show you this, but this is just a sample of the data that we have. So we have the lat long that we provided. Our measurements here were in whole inches. So this is how we've asked our bridge unit to provide it to us, is by lane and then by whole inches. So we didn't want fractions of inches. We didn't want probabilities of inches. Just give us a number. So, lane 1, which for us is the far right lane for that for that roadway was, in this case, 295 inches. Lane 2, which is the one next to it, the left lane in this case, was 296, or sorry, 286 as an example. Then we have zeros in here where there wasn't a lane. So as we mentioned, it goes out to 6 lanes. We had potentially in our database, but zeros just mean there was no lane there. Okay, so one of the challenges we had was actually this structure and things similar to it, trying to identify the roadbed that the restriction applies to. So this is that sign bridge I was talking about. So these two, the two left lanes over here, this is I-5 northbound, heading up to Seattle. So it's probably, I think, 5 or 6 miles south of the Washington border. And then these two right lanes out here, this is I-405 northbound, where it merges with I-5 northbound north of in North Portland. So I-405 is kind of a loop route through downtown, and this is where it merges back on northbound. So you can see there's 2 lanes of I-405 and then 2 lanes of I-5 crossing under the sign bridge. Just a few feet down the road is the Gore Point, where then you have 4 lanes of I-5, and then maybe a half mile down the road, this outside lane becomes an exit lane out to Swan Island. So what do you call this thing, and how do you do that, and how do you make sure we get it right so that it's applied in the system, just in case we had something really high that needed to cross underneath it? So reality for this particular one is that we have low structures on both sides of it, so it really wasn't a realistic problem. It's just not ever going to have or probably never going to have a really high load crossing under just the structures, because there's other lower ones on either side. But it was still a good exercise to go through, so we can figure out what we wanted to do and apply that to other parts of the state. So we end up with 2 restrictions on this one being needed. So this is some of the data from the back end of Orion. You can see this diagram on or this map on the left here, showing I-5 northbound, where they applied that restriction, and then the same sign bridge but a different restriction on the I-405 northbound main line before it merges. So kind of how we ended up doing that, just to make sure everything gets covered properly. Another challenge that we had is kind of, where is that structure? So this is, if you look here on this overhead view, this is a sign bridge over, I don't know if it's entrance lanes or exit lanes where this is, but these are on some auxiliary lanes on the outside. The 2 main through lanes on I-5 southbound are out here, but where do you put this bridge so that it shows up properly for height routing? That was a good question that we had to deal with. So in our old system, we on the permitting side would have put this structure either at the where the exit lane or exits from the freeway, or where the entrance lane merges with the freeway, which then would have blocked the entire, or potentially blocked the entire lane from being used if something was over height. So we, fortunately, with the newer technology, with automated routing and the things that we have in Orion, we now know exactly where this is, and this thing could be, if something were really high, it could be routed out into the main lines to get around it and not cross underneath it. Or if we had something really, really wide, over 24 feet wide or something, we would know what the height is, so that we can then work with the carrier or work with our geometronics team to get some good measurements on that, to make sure a load could fit under that structure, no problem. Okay, another example. This is on I-205, kind of an east on the east side of Portland. So 205 is an older loop ramp that loops from south of Portland up to Vancouver, Washington, north of Portland, but it goes around the east side. And so this down here, the actual I-205 main line is below this. So there's a bridge over I-205, and then you have this tubular sign structure thing over I-205. So, over the overpass over I-205. So we need to get all those measurements in there properly and make sure that we know where they are, we know where the structure is. And it did get challenging at times to figure out where things are, because as we were digging deep into the database and trying to figure out where things were, we noticed that some things, just in our database, just from having multiple hands in it over decades, maybe it was keyed wrong 30 years ago when they built the thing. We had to have some of the data, the actual background data, get fixed a little bit in order to make sure that we knew where all of these things were, or confirm that a bridge was where they said it was, or maybe it was new construction, or the bridge that's showing up there isn't there anymore because they took it down last year when they reconstructed the roadway. Whatever the story is, just lots of things that we learned as we went through this. So this particular example, we have 2 exit lanes, exit lane 1, exit lane 2. They're going to end up crossing under this thing, but of this right exit lane over here, whatever this is, it doesn't cross under it. So we want to make sure all that is documented properly in Orion, so that we could route we could route over height loads appropriately. Another challenge that we had was when the data came over or comes over from our database for, what do you call the structure? This example there is exactly what's in the database. It's, I'll read a bridge ID 20273 northbound I-5 connector 1WS crossing under cantilever sign, which is completely true if you know how to interpret all that. So I think northbound I-5, I think that makes sense. But connector, who knows what does the traveling public know what a connector road is? Can they read, the bridge ID 20273? That's on a little plaque that's, bolted onto the side of the bridge. And if you're going really slow, maybe you could read it. And almost nobody outside of the Department of Transportation, I think, knows what 1WS means. Or we all do internally, but that's a connector designation that we have from the main line. And it's complicated, but we had to interpret that or rephrase that to where something that customers can understand. So we make this one, for example, I don't know exactly where this is, but it would be potentially northbound I-5, exit 303, ramp to Swan Island, crossing under cantilever sign. That makes more sense, and the motor carriers and traveling public will know where that is, as opposed to connection 1WS crossing under some sign somewhere, not knowing where that is. So we had to get them, as the last bullet point says there, we had to rename some of them to clarify things and make sure that they understand that we have it in the database what it is that we're trying to get across. And then another challenge was, I think this is the final one we have for challenges here, was just the mile posting. So was definitely essential in setting these restrictions. So in Oregon, we have unfortunately a very, what I think is a very complicated mile posting system. I don't have no idea how other states do it, but I just know ours is really weird because we actually have two numbering systems in our state. So we have what we call the maintenance number or the highway number, and this is a system set up like in the 1930s when like the transportation department was first built for designating state highways. So I-5 is Highway 1, even though I-5 wasn't in place, in the 1930s. You get that, but it somehow was Highway number 1 is I-5, and then it goes not sequentially, but it goes up to I think as high as 492. And there's no rhyme or reason to it. They're just kind of all over the place for what your highway number is. Then in the 1950s and 1960s, they overlaid the route system and the shields on top of that. So I-5, US 101, I-84, whatever on top of that. So I-5 is fortunately, that one, it makes sense. It starts at milepost 0 in California and goes up to 308 point something up in at the Washington line. It's one of the few that actually is pretty good. US 20, for example, in our state, it starts at the coast in Newport and goes out to the Idaho line out by Nissa, and it restarts its mileposts 5 times. So there's 5 milepost 0 on US 20 in Oregon. And I don't know if other states have a similar situation, but we certainly do. So it's a little bit complicated trying to get to understand that. It's one of the hard things I have when I'm training new staff, trying to have them understand that. And it usually takes a couple of days for it to kick in for them to understand. I do remember the meeting we had with ProMiles trying to describe this whole highway numbering system that we have. And it was an interesting meeting trying to have them get it, but they got it. And once you get it, it kind of makes sense. But certainly was a challenge, but having it and understanding it was definitely good to have good to put in there where all the overheight clearances are. All right, so how a truck is routed. So if it's 12 feet wide or less, the truck is routed in the rightmost lane that it fits in. So we assume for freeways, 12-foot wide lanes, which most, I think that's standard, 12-foot wide. For the non-freeways, we also chose to assume a 12-foot wide lane for those because I'm pretty sure those are. I mean, possible there are 11-foot wide lanes, but we'll get into kind of how we've always done it this way and how we don't think that's an issue a little bit later. But for road beds that have more than one lane, we route it into the rightmost lane that it fits because that's where the freight traffic should be and the big stuff should be and where the traveling public expects it to be, as far right as practical. If it's more than 12 feet wide, it's routed into the rightmost 2 adjacent lanes that it fits in. So if it's a place where there are 3 or 4 lanes, and it can't stay in like the far right lane, for example, it'll route, Orion will put in their instructions to use the center lane and the left lane to cross under that structure. Don't use the right lane. So, or if it's the left lane they can't be in, it'll instruct them to use the right lane and the center lane to cross under that thing. So we're just we're telling them we're not where to be as opposed to where not to be. And this it only works with three, if you have 3 or 4 lanes in there. And we'll talk about an example here in a bit of what happens when you only have 2 lanes on your freeway and you have a height restriction there. And then for more than 24 foot wide, that gets way into the super loads, and the carrier has to do some work to help us make sure they can fit under those things. There's usually route surveys and a lot of other things involved when they get that big. So we'll definitely help them with it. We have the heights, we have the LiDAR data if we had to go look at original data to help determine if something big could actually make it. But we have to. The carrier has some additional work to do. Unfortunately, not too much stuff is more than 24 feet wide that we have to route, which is good. Okay, so just kind of summarizing the pros and the cons of it. So our pros, the main one is, as I mentioned earlier, is to keep the bigger stuff on the freeway. It decreases travel time and expense for the carrier to keep them on the freeway if we can, instead of having to detour them off onto secondary roads. There's always, by definition on a freeway, at least 2 through lanes of travel. So that's more room, for regular traffic to pass the big giant loads that are going. This picture here is kind of cool. This is a load I routed several years ago in our old system. And it's just a big giant transformer that was too big. It's like 18.6 high or something like that, trying to get to the southern part of the state from the Portland area, so several hundred miles. And it couldn't go down I-5. It had to actually use our secondary route, which is US 97 through the center part of the state, and mostly a 2-lane highway. And so this thing had to run at night. It took them like 3 or 4 nights to get to the southern part of the state. They got there and they got the transformer delivered and everything, so that was good. But just an example, like if it were, could have fit, which it didn't, but it could have stayed on I-5. It might have been a 1 day or a 2 day move instead of multiple nights trying to go down 2-lane highways. So another pro is we put the turn-by-turn instructions, we inject them, that's the cool term for it, into the turn-by-turn instructions, and we make it red text on the PDF if they can see that. So we include the clearance ID and then additional information, the local name, exit number. So you can see in this example, clearance ID 10806, which doesn't mean anything to the carrier, but definitely helps us when we're looking at the permit. We can figure out which one it is that we're looking at in our system. Eastbound I-84, crossing under the West Immigrant Springs interchange, exit 234. So that tells them where they are. And then milepost 233.95, exactly where this structure is. They have to use the left lane crossing under that structure. So there's miles on there, cumulative mileage, and so it gives them plenty of time to get out into the left lane where they probably aren't going to be, but we want them to be there when they're crossing under that structure, because if they were in the right lane, they would potentially hit the bridge, which we definitely do not want. So get out there in the left lane where you need to be. So the cons, a few cons, and this is one that we talked about earlier, is this things like this. It's a complicated numbering system when you have multiple lanes. There's confusion about what's the right lane. If you're on I-405, this is the right lane, but it becomes an exit lane. If you're on I-5, this is the right lane, but 30 feet after you cross under this bridge, now it's lane 3. So which lane is it? So we in some cases we chose not to use the lane-based clearance just because it was just too confusing to try to have it work right. And again, these are going to be exceptional situations, not common situations. So this is one of the exceptions. And again, doesn't matter in the real world just because we have low structures on both sides of this particular sign bridge. So not that big a deal to not have lane-based clearance under this particular one. One of the cons, and I have this in quotes here because it's sort of a con, sort of not a con, is the 12-foot wide lane. So before Orion went live, we did not consider lane width. All we considered was the height. So we didn't care if it was a 10-foot wide load, a 12-foot wide load, an 18-foot wide load. If the height worked for the lane, we would route underneath it, just use right lane or use left lane or whatever. Orion now, if the load is more than 12 feet wide on a 2-lane highway, it will consider both lanes. And if it won't fit in both lanes, it will then detour or route around or give a route failure if it can't find another route. So this is kind of one of our bigger ones that we've had to deal with. This is the West Immigrant interchange out in Eastern Oregon on I-84. So in years past, we would just use right lane under West Immigrant exit 234, and it would be no problem. With Orion, it would then start routing them onto the detour route, or still does actually today. The detour route is about a 5 mile detour on an old frontage road. It goes through a small little town in Eastern Oregon, and also past a state park. So is what it is. This summer, that detour route was closed for several months because they were replacing a bridge on it that was built in like the 1930s. So an old bridge, they replaced it. The detour route, the main detour for this didn't exist. So the secondary detour route was 400 miles on 2-lane highways to avoid this. Or can we find a way to keep them on the freeway? That was the question we were asked. And so we asked our geometronics and bridge team, well, can you give us the heights at different widths? So at 12 feet wide, it's only 200 inches. And then again, these are real inches, and we would take 4 inches off of that and then route for that. So that's going to be, it's either 16.4 or 16.8 for the real height. I forgot what the numbers are. But at 14 feet wide, we can still route underneath there. And even though they're going to be encroaching into this left lane, they're not going to be encroaching into the height buffer. So we can go ahead and route that and keep them on the freeways where it belongs. And then this decreases, as you would expect, the wider you get. So 20 feet wide, only 198 real inches is the max of vertical clearance if they're all the way over here on the fog line. We don't route into the shoulder in Oregon, and so we have to keep them between the paint basically. So it's possible that a 16-foot wide truck at 199 inches high, which I know we would convert that to feet and inches, but it would fit underneath the structure, which we prefer to do as opposed to put them on the 5-mile detour on 2-lane highways, or this summer the 400-mile detour on 2-lane highways, if we can. I mean, sometimes it just won't fit, so they have to take the long detour. Just how it is. We only in Orion right now, we only have the heights for the full lane. We haven't put this into Orion yet, and I don't think we're asking to anytime soon. It's something we're still fussing with because there are other structures in the state there. We have a similar situation to where it could move yesterday and there's plenty of clearance as long as we know there's enough clearance. So what do we want to do with that? So we're still fussing with this right now and trying to come up with a good plan moving forward. But we have one right now. Our staff are reviewing them, and our maximum auto issuance blank threshold is 15 feet 0 inches. So anything higher than that, our staff has to review anyway. So we're looking at those regardless. So how much do you use? So we have just under a couple thousand restrictions that have the lane-based routing. And as of yesterday, in a weird way, it's kind of only 222 permits have been issued with lane-based clearances. It may seem a little bit low, and as I was looking at this, it does seem a little bit low. But one thing I remembered is when a structure has what we in Oregon call an up and over, where you could take the exit, proceed through a traffic control device, and then get back on the freeway, as opposed to crossing under the structure on the main line. Orion will do that. It'll just kick them over to take the up and over, and that's what the carriers expect. That's what we expect, and it works just fine. So that may be why we don't see as much lane-based clearance for those few structures we have. They just take the up and over, and then that's what they're doing. So, but it does work. It works great, and we really like it. One situation where it doesn't quite work. I talked earlier about where it's hard to tell which roadbed you're on and which roadway you're on based on the paint that's on the ground. Another one is situations where we have zigzagging, which we have in Portland in a couple of spots. This is I-405 northbound, that loop ramp that goes through downtown, and there's a structure. It feels like when you drive on it, it's like every quarter mile, it feels like there's a structure. And if you get it right, and I forgot what the number is, I want to say 15.9 or 15.10 at the height, the routed height, not the buffered height, or not the real height, but the buffered height. You have to zigzag through on I-405. So you use right lane, use left lane, use center lane, and that's how we've always done it. And it has worked, and we've routed stuff that way for decades, and it's been fine. But it was just really difficult to get that programmed into Orion properly. So ProMiles has basically turned that off for these very short segments of where this is happening. So carriers can still go. They're just told to use right lane, left lane when going underneath these things. But the actual more than 12 feet wide doing strange things, that just isn't working. So in summary, lane by lane routing works. It does great. We've been doing it for just by default for decades, and we have it working out in Orion. Works pretty good. The pros and cons do need to be considered, of course, if you're going to make changes to how you do things. But our big deal is just keep things on the freeway, and if you can do it safely, go for it. Just this last picture I have, this is one of our our structures. It's on a county road, actually, not on a state road, but everybody in ODOT knows where this thing is. So it's on River Road, south of Salem, and yeah, it's a shortcut to get to this small town just on the other side of this trestle, and it's like 12'2" high or something like that. So it's really low. It gets hit all the time. I think there's a Facebook site that you can go to and you can follow them, and they've got a camera up on there now. They can just watch all the magic happen. So anyway, just something we obviously don't want to have happen for reals. Have it be a permitting issue on our side. So given that, that's the end of my presentation. So I think I will stop sharing, Ryan, and we'll see what kind of questions we have.
Yes. I think right now you have two questions. So the first question, Charlie, is if a driver makes a mistake and failed to stay on the right lane, does the system provide a contingency plan to avoid the bridge hit or a structure hit? It looks like this would be ideal for autonomous driving trucks to avoid human error.
Yeah, so I'll try to answer that. Yeah, we tell them on the permit, use left lane or use right lane. I mean, if they choose, I'll put it this way: if they choose not to do that, then that's going to be a permit violation. They didn't do what we told them to do on the permit. Obviously, we don't want them to hit it, any more than they want to hit it. That's part of the reason why we have the 4-inch buffer. That I guess some of the reason why that's in there is to prevent that, even if they miss it. We don't want them going into the buffer at all, but at least that gives them a little bit of leeway for where, if they do miss that instruction or can't do it right. I will mention we do have another. I don't have it in, or we don't have it in the slide. There's another part of I-5 southbound in Portland that we actually put a lower height limit on because there was one of those zigzaggy situations at a fairly low height, 1410 or 1411, and we had several carriers last summer that just were not following their instructions on the permit and going on I-5 northbound, which is what the instructions told them. They were going I-5 southbound, which was the shortest way to get to where they wanted to go. And so we turned off, we ended up setting a hard limit just on that little stretch of highway just to prevent that from happening because we got tired of loads being off route. So I hope that answered. If I didn't quite answer it, or you want to clarify, whoever wrote that, feel free to.
All right. The next one you have here is when routing by lane, how is enforcement handled?
It's the same thing. It's a permit violation if they were to be in the wrong lane. I doubt that our enforcement staff are out there, looking to make sure that they're just, standing at the bridge, looking to make sure that they're in the correct lane that they're supposed to be in. But it would be a permit violation if the carrier chose not to be in that lane.
Thanks, Charlie. There's another question here. They say they're curious. Are you guys doing a load rating check for permit truck crossings of any bridges?
Load rate. So yeah, that's a little different. So I'll try to let me get this out of my head. Yeah, so we have in Oregon, we have weight tables. So there's certain weight tables which are axle weights and spacings that we're allowed to permit without needing to get an engineering review. So if any of you are familiar with our weight tables, weight table 3, 4, and 5 are our heaviest weight tables, and they allow, depending upon the situation, 43,000 pounds on a tandem. Things like that. So only if it exceeds those limits that our permit office is allowed to permit, or it's crossing a weight, the carrier for whatever reason is requesting to cross a weight restricted bridge in excess of the weight limits, then it becomes a bridge review. But we don't do a load rating on every single heavy load. I want to say we do 400 or 500 a year. That might be high even, loads that get sent to our engineers for a load rating review prior to movement. Pretty much almost everything we can actually issue in our office, not that heavy.
Okay, and kind of tied to that, I think the next one, this might be the same answer, says if there's any circumstances that lane-based positioning is used for crossing over structures, bridges due to capacity of that bridge.
So yes, that does happen. Our bridge team, when they are reviewing it, they will sometimes say, straddle if it's a 2-lane bridge, for example, straddle the center line going across it, or use a certain lane in a bridge. That did actually happen to me several years ago when I was an analyst. It was on a 2-lane highway, and they were heading southbound on the road across a bridge, and the instructions from our bridge unit were to use the northbound lanes to go across that bridge. So yes, they had to set up traffic control and certified flaggers and all that to use the appropriate lane and maybe even slow down to 20 miles an hour, 10 miles an hour, something like that, and then get back on the the road in the correct lane. So yes, that does happen from time to time, but that's a different scenario than vertical clearance routing that we do. But it does happen from time to time.
You got a lot of questions, Charlie. They keep coming in, so we'll
Bring
run
it.
we'll run the next 20 minutes through all these questions. All right. So
Yep.
are these permit loads that are being transported all escorted by law enforcement?
No, they're not. So in Oregon, we don't require law enforcement for oversized loads, or because we don't have agreements with the state police. I mean, if the carriers want to, I'll use the term contract. I don't know if that's the right term, but they want to use state or local police presence to help them move loads safely. They certainly are welcome to do that, but we don't require that as part of our permits. We in Oregon, we're pilot vehicles and blinky yellow lights, not blinky red and blue lights.
Thank you. All right. The next one says, are all of your clearances stored with the bridge information and bridge is responsible for that data? It says we have two systems we have to combine: vertical clearances in bridge and vertical clearance a consultant sends us, and we have to take the lowest vertical clearance.
Yeah. So let's see. So as I mentioned, I may ask you to repeat that if I don't quite get this right. But yeah, our geometronics team, they collect it, they give it to Bridge, and yeah, we've asked for essentially one height, one lane, one structure, one highway, one milepost, and of course one lat line would be tied to that. For what is the height, the whole number in inches? What is the maximum height for that lane under that bridge? I don't know all the background for how that gets, what work is involved in that, because I'm not an engineer, so I can't speak to that too much. But I know they talked about, do you take your measurement off the flat, or do you do it off the banking, or if there's ruts in the road, where do you measure it from? And they all had to figure that kind of stuff out before they gave us the data. So I'm not familiar with that stuff. So we don't take consultant data and get it. We actually officially get it from ODOT teams that provide that to us. Does that kind of get it, Ryan?
Yeah, I think you hit it. I think
Okay.
they have they get some different variations in their
Yeah.
clearance height, and they take the
Yep.
lowest one,
Mm-hmm.
obviously.
Yep.
The next one here just says, which lane needs to be taken? Is it printed on the permit?
Yes, it'll say use right lane or use left lane or use center lane. And I work with, when we were building this thing, I worked with Tim for, you got the right center and left center lane. So we tried to keep it as clean as we could. But yeah, in the example I showed, I think it said in red text, use left lane under the West Immigrant Interchange, of Milepost, whatever. So yes, we do tell them which lane to use.
I think there was 15 possible
Yeah.
combinations, but I don't think we ever actually hit all 15 combinations in the real world.
Yeah. Yep. Yeah. In Oregon, most of ours are 2 and 3 lane, just a very occasional little short stretches of 4-lane freeway that we have. But most of our stuff's 2 and 3 that we have.
All right. And then this one might touch the same thing. It says, how does the driver decide this in real time? The GPS systems they're using is providing them a lane-based information in real time, or does ODOT have a routing QR code that they route on?
Well, the permit has a QR code. I know that it has all the routing information on there. Yeah, but I guess we're getting into my ignorance level. I don't know how that ties into any GPS systems that might be in the truck. But it would be their responsibility. They would still, regardless of what their GPS is telling them, they need to follow. I keep doing this like a paper copy, but they need to follow their paper or their PDF on their device for the routing that we give them. And if they get off route, that could, there's a permit violation at least, and potentially catastrophic if they get off route and hit something that we're on a route they shouldn't be on.
And then how did you arrive at the 4-inch buffer?
That one's been longer than I've been with ODOT. So as I understand it, it used to be 6 inches, and then sometime in the very early, like late '90s or early 2000s, they reduced it to 4 inches. So I'd have to go with it's always been that way, at least for the last quarter century. I don't know where that number was picked from, other than just how it always has been.
And then I think there's just a question about how the permit route is provided, text or map. Are there any plans to provide a GPX, a KML, or an electronic route?
That one, we don't, in our in ODOT, I don't think we don't have any plans to do it right now. I don't know if Tim, you can talk from a technology standpoint. I don't know what would be involved in doing that. I mean, I know if the carrier's in Orion, they do see a map and it's got a blue line on it, and they can zoom in and see all the up and overs and the routing and everything. I don't know.
Well,
Complete ignorance on it. So
there is a permit route or the permit navigate or route guidance app that a number of states are using. We have not discussed that in Oregon much. That the decision to use that, of course, I think is way above my pay grade. But it's certainly something. If your office would like to talk about it, we'd be happy to, and it should. It'd have to be tested, of course. It should provide the information on in a pretty accurate location of where they need to be in the left or the right lane. But again, we've not really talked about this. We've talked briefly at the start of the project, and then we worked our tails off to get the project done.
Right. Yeah. Thanks, Tim. Yeah, I would echo that. Yeah, we're only 7 months into it, so we're still kind of let's get it done, let's get it work, let's get all the little kinks worked out and everything. Then we can start considering other cool things that we can do with this. That'd be my take on it.
All right, this is a little bit different of a question. It asks if you can briefly speak on your org chart as it pertains to clearance and permitting. Are the clearance collection people or persons within the same unit as the permitting department?
So no, they're not. So the geometronics unit or group or whatever they are, they're the ones that collect. They're like, and hope I'm using terms properly, but they're surveyors and not remote sensing, but they're like a surveying group as I understand it. So they bought this, when they bought the mobile LiDAR several years ago, that's when they decided, hey, let's talk about using this for vertical clearance as well. So they're a separate unit. They give the data to our bridge program unit, and they're a separate unit altogether. They're definitely engineers that then look at it and review it and do whatever they do with it. Then they give it to the over dimension permit unit, starting with me because I'm the program coordinator. I'm not an engineer, but they give it to me, and then I review it and look at it, and then I may have some other people look at it if it looks kind of weird, or I just go, okay, it looks fine. Hand it off to ProMiles, who's obviously not ODOT, and then they go and key it into Orion, and then over dimension permit unit staff and then other specialists that we have in the unit, they'll then use the data that's in Orion to route or answer questions. I think that covered it, Ryan. Did I get it kind of right?
Yeah, I think you covered it. Okay, so I think a bunch of these are the same ones. I think I'm getting this a few different times, so I'll ask this all once, but should cover at least 5 people here. How many bridge strikes have you encountered, if any?
We've had 0 since Orion went live. We just haven't had it, which is great. What was that?
Said knock on wood.
Yeah, exactly. That's what we want. I think in the last, almost all of our bridge hits, I'm just trying to get it out of my head. Almost all of them have been either that we've had in the last several years, even when we were hand typing permits, before we had Orion, they were all either off route, which I talked about, and that was the I-5 southbound example. They were off route. They were supposed to go northbound. Now they're southbound. Now they're 15.6 high, and there's a 14.10 bridge right there. Now what do we do? Or they've been under permitted. Like they told us they were 15.2 and they were actually 15.6. And they hit something, or they were like not permitted at all. They were either bootlegging, or it was, example we've seen a few times, they don't put the boom down on the excavator, so the thing just illegal load, but if the boom is just flopping around back there, it happens to flop up and hit a bridge. That's could lead to a situation. So that's what we've had. We definitely haven't had anything in Orion that's hit anything, but it's been pretty safe. So as long as people stay on the route and we have good data, it's working well.
All right. And how often are the clearances updated?
I believe there's a plan. The plan is to update, I think, the main lines, the freeways, every year or something like that, and then update all the other routes every 2 years or something like that. There's a plan to do that. I don't know how well that's being followed. I'm not aware of that. It's not a place really for me to ask the question, like, how are you guys doing on your review of the route? So we do get updates from time to time. We'll just randomly get an email from the bridge guy, hey, here's some new heights for you. Sometimes we'll ask for new heights, like if we're not sure of a structure, or If we're pretty sure there's new construction because we're just driving around ourselves as citizens, like, there's a new bridge right there. We should probably get the height on that. But there are plans, there are processes in place when there is new construction or new bridges put up for them to tell us about them. So it's supposed to be a regular, consistent thing where they get measured. I just can't speak to how often, if that actually happens or not. I suspect it does, but I just can't speak to it.
That's fair. Okay, so how many oversize of weight permits do you do on a day in average?
Um, Daily, I think it's around 300 ish a day, single trip permits that we do. I think the numbers we've been throwing around for the last few years, we do about 35, no, sorry, about 70,000 single trips every single year, depending upon the year, plus or minus a little bit. So it works out to be, 300, 350 a day, something like that. Busier in the summertime because that's our, more daylight, better weather, and less so in the wintertime, and even a lot less now it's getting into Christmas. We're not doing near as many single trip permits.
All right. So this one says, for lane-based clearances are they captured during routine structure inspection, or is there an automated technology used that captures this?
They're not. I don't think they capture it during the routine bridge inspection. They might. I don't know that off the top of my head. It wouldn't surprise me if they do, just because they're capturing other stuff. But I do know we use this lidar thing that I talked about. That's where the official height data comes from, and I don't know the process of. I know it gets scanned. I've seen some cool stuff, and they've explained it to me, and it's pretty cool. But ultimately, they do something with that data, and they present us with one number for what the vertical clearance is. So it doesn't come from inspections. It comes from the surveying that's done throughout the year.
All right, and we got a few more still here, Charlie.
Yep.
So we'll
Yep.
run till
Let's
the
go.
end here. How do you manage width restriction within the system?
With it's a different type of restriction. So so we have. I guess I'll mention we have temporary. We have temporary restrictions for construction type work. So those are put in just kind of as, I can't remember the exact terminology on it, but those are put in if there's like a 12-foot width restriction for paving project in the summertime. Those will get put in the system, and then Orion will route around it. Or if it's just like a nighttime width restriction, will put it on there as a warning to the carrier. Just don't go during these times, or do go during some other times. So for temporary restrictions, that gets done. The permanent width restrictions, we have a few of those in there. We except for that one I showed you in one of the early pictures where it's restricted like 35 feet long. I think we might have an 8'6" legal width restriction on that road as well. Never gets used for anything because is an old scenic highway. But we also cover our permanent width restrictions, with pilot vehicles. That's another one. We have some route maps to kind of describe how to do those, or how we're supposed to route based on that. And it's been an interesting side project trying to get all that kind of stuff in our length restrictions into Orion. But it's worked pretty well to make sure that generally the bigger stuff stays on the better routes. That's what we're trying to do.
Perfect. And then is there, I guess, real quickly, we're talking about the 4-inch clearance there. There's a note in here that California gives 3 inches.
Mm-hmm.
So if anyone's
Yeah,
interested, that's
I think I've heard
California's.
like I don't know if anybody in North Dakota's on. I think I've heard they change there's like, in the wintertime it's 6 inches because of all the snow they get, and in the summertime it's 4. So it may change in different states. I've heard that.
All right. So this one asks if there's any form of confirmation that these trucks are using the proper lane for clearance or capacity. And it says that their agency got away from this because folks weren't following the lanes that were indicated.
Yeah, good question. I would have to say no. We don't have a way to do it. We don't have a routine way to do it. I guess I'll put it that way. We put the provisions on the permit to use a certain lane for height or weight or whatever, and for lack of a better term, we just trust that they're going to do it. Occasionally, we will have a move will be monitored where some local ODOT staff will want to go out and watch them just to make sure the carrier is doing it right, or it's such an unusual, bizarre move that they're trying to do, or some weird equipment we haven't seen before. They'll want to go out and monitor and watch it. But from a routine standpoint, we just issue the permit and trust the carriers to do the right thing.
All right. And then another question is if this also includes signal head heights.
We do not have signal head heights right now. We only have bridges that you would think of, overpasses, railroad trestles, sign bridges. We do have those. We used to not have the sign bridges in there. We just kind of like, good luck with the sign bridges, bye. But now we have those in the system. We don't have signal heads. We don't have mast arms for like lighting structures. We don't have those wires. We don't have any of those in there. Wires will probably be a never thing that we're going to do because they move around too much. And we've talked about doing mastheads and signal heads, but we just haven't gotten to that point yet.
So how many people do you have in your permit office?
We have.
I guess there's more to this question, Charlie. Sorry. It says,
yeah.
You have people in your permit office that deal with permits, and then people in your permit office that deal with clearance information that goes to ProMiles.
The clearance information, it's not a big body of work that we do. It was certainly to get the information to ProMiles to put into Orion. That was a lot of work. That was me. I was spending a lot of time, and a couple other people in our work unit. We're spending quite a bit of time getting that data and making sure it was right and getting it over to ProMiles. So we really don't have. It's not a big deal. Like right now, we get new heights, and I look at it. It takes a few minutes to go. Oh, yep, looks good. Ship it off to ProMiles. I don't know how much time it takes them. Tim would have to speak to how much time they spend on it. I don't expect it's a lot of time, but it's certainly not not a significant amount of time that we're looking at new vertical clearance data unless it looks weird or looks bad. As far as permitting staff that we have, I think we have 9 staff members right now that are writing permits, and then some other specialists, myself and a couple other specialists doing weirder things with permitting. But I think we have 9 staff members right now issuing permits.
All right. And then does your state require bucket truck escorts or pre-qualified signal contractors? And if so, at what heights?
Let's see. When a load gets to be 17 feet or higher, that's one of our magic numbers. We are then required in the permit office. It's not an auto issue, but we're required to get with our ODOT electrical crews to have them look at the route and then either confirm it's okay, there's no problems, or actually start doing working on some potential traffic control plans or route surveys for that. So it does include, or has in the past, I've seen it include bucket trucks when they're 19 or 20 feet and they're moving things. Sometimes ODOT, I've just seen different things. So sometimes ODOT staff will go out and move the lines for them. Sometimes they'll allow them to contract and use their own. The carrier can use their own bucket trucks to move the lines. We'll go out and watch them or whatever to make sure they do it right. So I would say depends on the situation and how high and where they are and how long the move is for what we'll allow or what we'll let happen for that situation, but not routinely no until it gets above 17 high at least.
All right. And have you analyzed any origin, destination, or commodity time of year patterns of the permitted routes?
We haven't done commodities yet. We actually, part of what we implemented with Orion, we used to have this very detailed, we required a specific commodity information for what they were moving. And now we've gotten to much more broad categories that are based on economic indicators, like instead of, a feller buncher or a log loader, now we're just doing a high level logging equipment. We have construction equipment and wind tower components. We have, I think, 8 or 9 or 10 different categories. We haven't had a chance yet to analyze that to see what that's telling us, if anything. As I mentioned, summertime tends to be our busy season, more so than wintertime. I think generally Oregon's kind of a pass-through state for big stuff. So we have stuff starting in Seattle, Tacoma, at the ports up there, going out to parts east of here. Some stuff coming in from California or down to California, so going south and perhaps passing through the state. We have a lot of industry within the state as well. Logging is a big deal, so we have a lot of logging equipment, which is going a lot during a lot of the year. Construction, obviously, a big deal up here. So high level, that's kind of the patterns I've noticed over the years.
All right, you got a great job, by the way.
Thank you.
So you got a great job, and I thought I heard you say this, Charlie, but is it 300 permits a day that you guys do on average? Yeah,
300, 350 that get issued. So that's total issue. We're auto issuing right now. Around 40% of our single trips are getting auto issued by the system. We don't even look at them. And so
you answered the next question without even reading it.
Cool.
The question was, what's the auto issue percentage? There you go.
right at 40. So yeah, so the 300 or 350, that's a total, and then 40% of that ish is going to be auto issued by the system.
All right. So with that, Charlie, I think we're at time.
Okay.
So I really appreciate your time today. I appreciate all the time of all the attendees. As I said at the beginning, this is a new quarterly webinar series that we're going to be doing, and AASHTO's relationship with ProMiles and the permit route system that is now available to our members. So keep an eye out for more webinars, more newsletters coming out on maybe a quarterly basis. If you'd like to be on that mailing list, I put the link in the chat. Go ahead, give us your information. We can add you to those mailing lists. And with that being said, keep an eye out for this recording. And again, thank you to Charlie and Oregon DOT for being the first one up. And if there's a topic you'd love to present on or something you're interested in sharing from your agency, reach out to me and I will be sure to get you in the short list to do a webinar. But thank you, Charlie. I appreciate it.
Thanks, everybody.
Thank you,
Appreciate it.
All right. Bye.